Good morning, and thank you for joining us today for the webinar on the topic of roof design, the critical first step to long-term performance. But before we get started on that topic, we do want to take care of a few little housekeeping items. On the left-hand side of your screen, you will see the little handout icon, and that's where you can find your PDH certificate. This webinar today is good for 1 hour, 1 credit. We will be asking a series of poll questions throughout the webinar, and those will pop up full screen. You won't see them right now, but once we launch them, you will see them in place of the computer screen. If you have any questions, feel free to ask those. There's a little question mark button on the left-hand side. Feel free to ask those throughout the course of the webinar, and we will be answering all the questions at the end of the presentation. And a recording will be available for those of you that would like to look back or for those of you that cannot attend. So first up, I want to introduce my partner in this presentation today. Andrew Reynolds is a partner with Benchmark. He's been in the roofing industry for 10 years. He is a senior consultant and a licensed engineer from Iowa State, Go Cyclones. And his contact information is available on the screen there if you have any questions for him after this presentation. My name is Ben Fiedler. I'm a staff consultant with Benchmark. I have been here for 5 years, and I am a registered roof observer. Once again, there is my contact information. So a little bit about Benchmark real quick. We are a roof and pavement design company. We are independent. We are privately owned. We have no special interest with manufacturers or contractors. We really want to look out for our clients' best interests. We have 2 offices, one located in Cedar Rapids, Iowa, and the other in Waukesha, Wisconsin, as well as consultants based throughout the United States based out of their home offices. We do have one more webinar coming up in this 6-part series. This topic will be on pavement rehabilitation design goals. And I just wanted to take a moment real quick to mention at the end of this webinar, you will be receiving a survey. As soon as we hit end, it should pop up full screen. And one of the things we want to know is, are there other webinar topics you'd like us to cover? We have really enjoyed these, but we want to make sure that we cover topics that are relevant to those responsible for managing roof and pavement assets. So we want to know what you want us to talk about. And with that, we will go ahead and start the conversation on roof design. Andrew?
All right, thanks, Ben. Yeah, so inherently, the role of a roof is pretty simple. It's try to keep water out of the building. And while it is somewhat simple to put a roof on that's watertight, it can be difficult to make that roof sustainable and long-lasting. There's a lot of different variables that we're going to talk about today that you have to think about when you're looking at either putting on a roof for new construction or re-roofing. One of those weather-related elements is hail. Hail is a big topic right now in our industry. It is kind of an ever-moving target on how to design for it and what materials to use and when to use them. So it's a moving target, but we think we're getting there with it. Another one that's very project-specific is wind. You really need to know your situation with this. There's a ton of different variables that kind of compound on each other to come up with a proper wind design and wind uplift pressures. I'm going to touch into this in a lot more detail later, but pretty much the important thing is you really need to have a design professional do these uplift calculations even in section by section, because scenarios change even if roofs are right next to each other. And also to be fire resistant. This is kind of a famous disaster in the roofing industry. This is a GM plant. It was a transmission factory that was state of the art. It was about 4 years old when this incident happened. And there was a small fire that started in one side of the plant. It got up into the roof. It was all applied in asphalt. Pretty much we had there's tons and tons of asphalt, liquid asphalt coming into the building, caught everything on fire. It was a total loss. This changed a lot of things in the construction industry, including firewalls. And it also triggered things like no more roofs being installed with asphalt directly to decking, So it was a big event, about 1.5 million square foot loss, sparked a lot of things in insurance for insurance requirements as well. So it's definitely something that we look at every single project we do. Ben's going to touch on this more later, but this is a hotel property in Hawaii. Solar is still popular as ever. It's getting more popular because it's getting more cost efficient. You really need to have a lot of communication when you're doing solar products. You're going to have an electrical engineer. You're going to have a structural engineer, and you're going to have those parties talking early. And the need or want to be green roof ready. And again, I'm going to touch on this later, so I'm not going to spend a lot of time on it now. So I'm going to kick it over to Ben, and he's going to talk about the roof design process.
All right, thanks, Andrew. So as you can see, there's a lot of different logos on the screen, and each one of these organizations have a different impact on the roof design process. And the first thing we want to touch on is trade associations. So that would be Anti-Spry, ERA, Asphalt Roofing. All these trade organizations try to develop standards that help guide best practices in the industry. So for example, Anti-Spry has developed a lot of really high level edge metal standards as well as gutter standards. The next thing we want to think about is insurance requirements. So many facilities are factory mutual or other large carriers, and they have a lot of their own requirements, and they set a lot of standards as well. The next thing we need to think about is your local municipal government level restrictions and standards, such as Miami-Dade in the Florida area. They have a lot of hurricanes in that area, and so they have a lot of standards that help reduce the risk during hurricanes. And the last thing we want to think about is building codes. And building codes actually often adopt insurance company and trade association standards and codify them. So for example, Anti-Spry's ES1 edge metal calculation is codified, as well as a lot of Underwriters Laboratories standards. So let's dive deeper into the building codes section of that, and that's the first thing we're going to take a look at. And building codes in the US and across many other countries have been developed by the International Code Council. The code has been developed by not just a governing body, but it's a group, it's a committee that is developed from various interested parties. So builders, facility owners, insurance companies, they all come together to help develop these standards. And the main 4 code standards that apply to roofing is the International Building Code, the International Energy Conservation Code, the International Existing Building Code, and the International Green Construction Code. There are other codes that apply to roofing sometimes. For example, the Plumbing Code has a lot to do with drainage. However, only a small portion of those codes apply to roofing. So our first poll question we're going to ask today is about codes. And so I'm going to go ahead and launch that. So you should see it now. And the question is, what version of the International Building Code is adopted by your authority having jurisdiction? So that would be either your city, your county, anything like that. The options are the 2012 International Building Code or earlier. I think there are a few counties that have an earlier code adopted. The 2015 International Building Code, the 2018 International Building Code, or if you're unsure. And I know a few people on here manage facilities in a lot of different areas, so one might not apply. And so Andrew, earlier I mentioned that you are a licensed engineer. And so what is your specialty in engineering?
So I went to school for construction engineering, but it's a civil background. So I have my civil PE license.
Very nice. Getting quite a few responses in here, and the results are a little interesting. Give people a few more seconds to get their votes in. and we'll go ahead and close those polls, and I will go ahead and share them. So 5% voted that they're on 2012 or earlier, 27% voted 2015, 24% voted 2018, and 43% voted other or unsure. I'll go ahead and hide that. Advance that slide real quick. So building codes start their lives actually as a recommendation. The Code Council isn't associated with any government organizations. However, those governments then adopt the codes and write them into law. And so at that point, they do become law and they're no longer a recommendation. Every state in the United States has an adopted version of the code, which means every building in the US has to follow code to some extent. Building codes were designed to protect the health, safety, and welfare of the human occupants. And they really set just the minimum standards to achieve that level. And that's an important thing to think about is they aren't the end all be all, the greatest thing out there. They are the bare minimum. And so you want to make sure that if your facility needs something more advanced, that you go ahead and go above and beyond what the code requires. The energy efficiency in a building is impacted by the International Building Code, the Energy Conservation Code, and the Green Construction Code. And so depending on which one of those is adopted, you have to check different places to see what your insulation requirements. And with that, we're going to go ahead and switch over and start talking about wind uplift.
So within the code, it actually, you won't find anything on how to calculate wind uplift. It references you to a publication called ASCE 7. There's different versions, 705, 710, 716. Those are just release dates that different codes reference. For instance, the 2018 code references ASCE 716. And this is just a pretty simple diagram. When you see a lot of pictures of failures of roofs, it always looks like it kind of peels from the edge, and it's usually not the case. Wind actually pulls the roof up off the roof as kind of like an airplane wing, if you want to think of it like that. So it's a negative pressure sucking your roof off, and then eventually it'll fail at the edge, and that untiered roof or unattached roof will kind of peel back, and that's where you kind of get those images from. But on top of that, you also get some internal pressures. So if you have overhead doors or windows or just regular access doors, when wind hits those, there is some sort of leakage. That's where you get kind of this impact that, okay, on a strong wind event, if say you have a loading dock that has a large overhead door, you'll get some air leakage, or if that door's open, air gets inside and it pushes up on the roof deck. So it kind of compounds. You got the wind on top, sucking the roof off, wind inside, pushing. So that's usually when you see failures, we see a lot of those situations. Like I said, you determine your uplift loads per ASCE 7, and also we'll touch on FM Global more. They their name's going to pop up quite a bit through this presentation, but they also have their own calculator that they use. It's based off of ASCE 7, but there's some kind of subtle nuances that usually result in having some higher uplift pressures when you use FM Global's calculator. But some things you'll need: building height and width. On older codes, those are used to determine your perimeter and corner zones. Design wind speed, that's going to vary depending on where your project's located. Parapet height, if you have a parapet height that's above 3 feet tall, you can actually get some breaks when you're designing your wind uplift, especially in perimeters and corners. Ground roughness, that touches pretty much on if you're out in an open field compared to a downtown area. There's a variable in there that changes, so you're going to get kind of a break if you have surrounding buildings that can block some wind. Occupancy category, this is a very important one. It's pretty much what's in your building. Is it a warehouse for finished goods, or is it a hospital, or is it a warehouse over some sort of fuel storage? Depending on what your building uses, it's going to change the requirements for your wind uplift. Roof slope, that'll change your, if you get high enough slopes, it can change your perimeter and corner zones. So it's important to know And then enclosure classification. That's if your building's closed, partially enclosed, or open. And there's some calculations to do for that. But pretty much if you have a building that has a lot of openings on one side, pretty much their thinking is wind can get into these openings and there's no way for it to go out, so it goes up. So it'll increase your pressures. So once you do all your wind uplift tests for each roof section, like I said, it's important to do it for each one because it will change as you go across, even on the same site, or even on if you have two roofs next to each other, they can change drastically. You need to pick a roof section or a roof system that meets that. So your research options are FM's roof nav. That's the big one. I'm going to touch on this a little bit later as well, but there's close to 1 million tested roof assemblies within Roof Nav's database. Miami-Dade uses some private testing laboratories, and then they review that and accepts those roof systems pretty much. UL does a lot of testing with fire. The ICC has evaluation reports available for tested roof systems. And then the newest one is SPRI's database for assemblies called DORA. That's slowly picking up. It's pretty much, it's a free site to use. Manufacturers can pretty much submit their testing. DORA accepts it and they put it in their database. It's a really easy to use database as well. RoofNav can get a little tricky. So if you're having troubles, I would recommend trying DORA. So like I said earlier, you're usually going to see your losses happen at your perimeter and corner zones. The first line of defense on this is your nailer attachment and edge metal attachment. If you don't have those two kind of buttoned down, you're definitely going to have, if you have a large wind event, you're more susceptible to having a loss. For a nailer attachment, there's really not a whole lot in the code for that. So I would recommend there's a FM Global data sheet called 1-49, and it goes over nailer attachment for all sorts of different scenarios. And then you want to make sure you have an edge metal system or coping cap that is designed to ANSI SPRI ES1 standards. That is in the code, that's a requirement. There's a lot of different ways to do that. You can have shot fabricated sheet metal that's tested to ES1. There are pre-manufactured sheet metal manufacturers that do their own testing and own manufacturing, so you could use systems like that. But it's really, really important to have a tested ES1 assembly. And then there's also a gutter standard called GT1. It's not in the code. It's going in for adoption on the 2021 building code, I believe. So that's going to become a new requirement. That's going to be really interesting because it's going to there's some really, really bad gutter details that get installed. So it's going to be interesting to see how that changes in the coming years. So this is kind of that background picture. You can see there's been a blow off here. And it started at the coping cap. This is not a great detail, just these clips kind of every 3 feet on center. It's really easy for wind to get up under that and pop it off. And once that coping's off, it's going to take your flashings. And then once the flashing goes, it takes the feel of the roof. And then this below picture, that's a ES1 test. It's called RE2. And pretty much it's just a cyclical test on that edge metal, pulling it off. And once it fails, you pretty much take that last passed test, and that's the wind speed or wind uplift that you're able to pass that edge metal at. Slope and drainage, I'm going to base this pretty much on the 2018 building code. For new construction, you're required to have a 1/4 inch per foot slope, whether that's structural or within a tapered system. Either or is fine, perfectly acceptable. And then for each drain or scupper, you need to have an overflow device. So if you have a drain, you either need to have if it's by a perimeter, you can use a scupper, or you can use just a standard overflow drain. And then if you have a drainage scupper, you have to have an overflow scupper next to it. For re-roofing, if you have a roof replacement or a recover of a low slope roof, you don't have to meet that 1/4 inch per foot standard. And you don't have to have overflow devices installed. You don't have to upgrade to meet code. So when you're talking about drainage, what you want to have, you need to know how does it slope? Is it tapered or structural? Can you improve drainage? If you're doing a recover and it's a tapered system, is there a way to install additional tapered insulation to take care of any problem areas? Is there enough drainage? If you noticed that your roof is always holding quite a bit of water during rain events, is there any way to add additional drains or add scuppers in? It can be expensive, but sometimes it's necessary, and it really kind of becomes a life safety issue, especially if you're holding a lot of water on your roof. You're more susceptible to collapses. And then, do you have sufficient enough clearance at units, windows, door thresholds, through wall flashings, etc. It's really important to know how thick your roof system is going to be and have those elevations so you don't run into any flashing height issues during installation. This is just a standard tapered insulation layout, just in here kind of for example. I put this in here because I really feel like it kind of stresses why it's important to have a design professional do something like this. If you leave this up to a contractor, they're gonna probably hand sketch up what the roof kind of looks like, put approximately where the drains are, and they're gonna shoot it off to an insulation manufacturer, and they're gonna pump out something that probably would look similar to this, but they're not up there trying to figure out upgrades, ways to make it drain better. So I'd really recommend that you utilize a design professional if you are doing a somewhat complex tapered insulation system. So environmental regulations. So once you've kind of taken care of all your building code requirements, wind uplift, drainage, stuff like that, you need to think about where your project's located specifically. The two big environmental regulations that we kind of run into right now is a South Coast Air Quality Management District that kind of focuses around the Los Angeles area. There's a few counties that are kind of wrapped within that. And then the Ozone Transport Commission. So that's kind of the Northeast United States. It's in here, think of original 13 colonies. So those two districts or those two areas actually restrict to a certain extent VOC content in roofing adhesives, primers, sealants, and a few other products. So say your standard bonding adhesive for EPDM is might have a VOC content of 500 grams per liter. They restrict it down to like 250 grams per liter. And I think South Coast might actually restrict it further than that. So really it pushes you to change to having to use different materials, especially for adhesives. You're probably going to have to move to a water-based adhesive, which that kind of restricts your installation time because you can't obviously have it out when it's freezing. Solvent-based, you can actually get some variances to install that in freezing temperatures. Besides that, you can still maybe use a solvent-based adhesive, but they might change the solvent in it, and that's going to change how it installs, and it's also going to change how it smells. And then beyond that, like I said, harder to install, kind of shrinks your installation window, so just something to think about. Insurance considerations, obviously the immovable object in the room is FM Global. They're the monster, they're the kings of insurance when it comes to roofing. Global Risk Consultants is also a pretty big one, but they follow FM reg. They don't have their own standards necessarily. They pretty much just follow FM standards. So Ben's gonna run another poll question really quick.
Yeah, so the question is, does your insurance carrier have specific design requirements? And the answers are yes, no, but our company has design standards. And I know a few of you on here definitely would fall into that third category. So we'll give you a few minutes to go ahead and get your answers in. So I don't know if you guys noticed, but a few minutes ago, there was a wagging tail that walked by. My dog Luna decided to come join me. And Andrew, is Arnie gonna stop by and see us today?
No, I locked him outside. Unfortunately, I'm sure he'd like to, but.
And so Arnie is what breed?
It's a golden doodle.
It's kind of fun in Andrew's office. He has a little photo gallery set up just of Arnie. It's always fun to stop in there and see that. give a few more seconds to get the answers turned in. And it looks like they have mostly been collected, so we'll go ahead and share. And the results are 51% said yes, they do have insurance-specific requirements. 9% said no, and 40% said they have company design standards.
That's good. Well, thank you for participating in that. So like I said, if you are FM approved or you follow their standards, one thing you're going to have to do is have a roof system that is approved by FM Global and FM approvals. And kind of to explain those, FM Global's the insurance side, FM approvals is actually pretty much their testing laboratory, and they pretty much put all these roof systems together into their database. FM has data loss prevention sheets also. I mentioned one of those earlier, 1-49, it's for roof flashings. That's where I kind of referenced you to go to for nailer attachment, but they have ones for hail resistance, they have ones for wind design, they have ones for just about everything, insulation attachment, stuff like that. So, like I said, if you do all your wind uplifts, you figure all that out, you figure out, you know, what you need, and then you go into RoofNav and find yourself an assembly. And like I said, over 950,000 available as of yesterday. So getting into hail design, put this map in here. This is from 2009, so it's comes off one of their loss prevention data sheets, 1-34. And this was the map for a very long time. So kind of that salmon color on the east, west coast, and down in Florida, that's a moderate hail rating, which is their minimum. So any of those 950,000 assemblies would at a minimum be rated for moderate hail events. Now, the light blue that kind of goes from Texas up through Wisconsin and Minnesota, that is severe hail. And so as of yesterday, out of the 950-some thousand, 935,000 of those were rated for severe hail. So it was really easy to find roof assemblies within RoofNav. 98% of them were severe hail. So really wasn't a huge issue until 2018. They changed their map, and this put a big kind of cramp through the middle of the US here. So the green areas on the coast, pretty similar to the last slide, it's moderate, so no difficulties there. The salmon color changed to severe, no issues, because like I said, 98% of the assemblies are for severe hail, not a huge deal. Well, then they added very severe hail, which stretches down from Texas all the way up almost to Canada. They, for some reason, just stayed short. Gave the guys up there a little break. But as of yesterday, there's only 41, just over 4,100 very severe rated assemblies within RoofNav, which is just over 4%. So it's put quite the cramp. If you're a FM insured or you follow their policies within that centralized area, it is really difficult to find a roof assembly that is really acceptable. There are quite a few like modified bitumen assemblies over a gypsum cover board, which is a pretty standard roof system and one that we specify quite often. But if you want any sort of single ply roof system, right now, almost all of them, I can't say for sure all of them, but you know, PVC, TPO, EPDM, they do have assemblies available, but they use plywood or OSB as a cover board, which we do not recommend doing. If anyone's ever seen a slightly damp piece of plywood get baked out in the sun, it curls up like crazy. So, I mean, we're not 100% sold on using those systems. So it is driving a little bit of innovation in the industry, a little bit of change, but it is a difficulty right now.
All right, the next thing we're going to talk about is the occupancy considerations of your buildings. And, you know, recently we had a hailstorm that came through Cedar Rapids, and my sun porch roof ended up getting destroyed and needed to be replaced. So I had the roofing contractor install a adhered EPDM roof system. And for the first time, I knew what it was like to be in a building trying to work with a re-roofing project going on overhead. And the odor from the adhesive just completely filled my house. And thankfully, we were able to open the windows, and we were spending a little bit of time outside to get away from the odor. But you really need to be thinking about, if you have office space directly below your roof section, a solvent-based adhesive is probably going to cause some odor issues with the occupancies. There are some things you can do to work around that, such as using water-based adhesives, which have a lower odor, or changing how your HVAC system vents. The next thing you need to think about is the temperature of the interior space. And many food production facilities have, blast freezers that reach minus 40 degrees, and they'll have a lot different of a design than, let's say, an open canopy. The other thing you got to think about is humidity. If you are putting a roof on over a pool, or anything that has a lot of moisture, paper mills, you need to have considerations to prevent that moisture from entering the roof. And then the last thing you need to think about with occupancy is there discharge coming onto the roof surface from an interior process? Those can cause issues with roof membranes and very quickly destroy them. And so the first thing, let's dive in a little deeper on the odor avoidance. Asphalt is definitely on its way out as an adhesive. However, comparing asphalt to polyurethane adhesive, you definitely want to go with the polyurethane, because it has a significantly lower odor to it. We were talking earlier about VOC content, and one of the biggest misconceptions is low VOC adhesives smell less. And actually, more often than not, they have a stronger odor than a full solvent VOC containing adhesive. So just be careful of using that as a control system. PMMA coatings have some of the strongest odors in the roofing industry. And really just think about the fact that nothing really smells like nothing. Every adhesive on the market has an odor to it. If you install a mechanically attached roof system, while you won't be adhering most of your field membrane, there will be adhesives needing to be used on flashings and things like that. As a consultant, this photo right here makes me really uncomfortable. I never want to have to see that at a client's site. That's debris coming in from a re-roofing project, and the easiest way to avoid that is by installing interior protection. It's a plastic sheeting material. There's specialty contractors that install that. And right now, there's actually 2 contractors that have a material that's designed to be installed below your fire sprinkler system, which is a big deal because normally a fire marshal would not approve of that system. However, they have a seam in it that once it is exposed to heat, it automatically breaks away so that the fire sprinklers can work. So talking a little bit about the temperature and humidity situations, one of my mentors when I started in the roof design process told me there are 3 things that I really need to be careful of: infiltration, condensation, and saturation. And so infiltration is when warm, humid air is able to get into the building from the outside. That is your biggest issue in a freezer environment, because that humid air is going to condensate and freeze and create some very large icicles. And so when you're re-roofing a freezer, you really have to focus on making sure that you have really tight air seals and vapor seals on your perimeters and penetrations. Condensation is when that warm, humid air comes into contact with something that's cold and it turns into liquid. And so if you're in a high humid environment, you want to install a vapor retarder so that that warm, humid air cannot condensate inside your roof system, and that will prevent humidity issues. Saturation is when there's just so much moisture in the air that it has to come out some way. That's usually a sign of food processing facilities during washdown, not something that's impacted by the roof system. So we have another question, poll question. Does your facility have high-risk areas for vapor? And you can check all that apply. So you can check if you have high humidity, you can check if you have low temperatures, or if you're in an environment that has neither, feel free to check that. So on these projects, Andrew, that you have either high humidity or extreme temperatures, do you kind of find it fun working through those design processes?
I enjoy them. Not everyone does, but yeah, it's fun. I mean, you get to bust out the psychrometer and do some dew point calculations and stuff like that. It's definitely interesting, kind of something to keep you on your toes.
So one thing Andrew just mentioned is a psychrometer, and what that is, it's a thermometer takes temperature readings, a psychrometer takes relative humidity readings. You have to use that to establish where the dew point of your roof system is based on the humidity levels inside the building. Looks like our voting is slowing down, so we'll give a couple seconds more for any last votes to come in, and then we will share the results. All right. And the results are 51% of attendees have high humidity environments, 23% have low temperature environments, and 51% have neither. Let me click back over here so I can advance the slide. So the next thing we need to talk about is contamination on the roof system itself. So this photo was taken at a food processing facility, and the facility had changed their internal operations in a way that made that vent go from not discharging any grease to suddenly discharging a lot. And the roof went from kind of what you can see in the background where it looks fine to this really heavily alligator look in only a few months. And so grease can really quickly cause issues. So you want to think about, is it possible to install a containment system so that that grease is captured before it hits the roof? Or do you, if you're unable to control it, you just need to install a membrane that will be resistant to your chemicals. If you do, you need to contact different manufacturers with your specific contaminant. Different materials have different resistance, and you just want to make sure that you find one that works with your particular contamination.
So going into energy considerations, this kind of goes back into the building code requirements again. And a few things to talk about: insulation requirements for code compliance, the cool roof, is it required or is it actually a benefit or not? And then air barriers, which I'm going to kind of finish touching on this slide. Air barriers have been a requirement in the IECC since 2012. And I'll get this one out of the way, they're not required in climate zone 2B. Not quite sure why they got out of it, but they're not required in roof recovers or replacements as long as you're not altering the walls. If you're doing a complete building renovation where you're stripping down, say you're taking face brick off or something like that and putting back metal panels, you're actually required to install a continuous air barrier at that point. But if you're just doing a simple roof replacement or recover, those aren't required. And actually, so typically an adhered membrane system, so if it's PVC, modified bitumen, whatever it might be, TPO, if it's adhered, those are typically accepted as air barriers. You do still have to, if it's a new construction or that large renovation, you need to tie that into the wall air barrier. But if you have a ballasted or induction welded or mechanically attached roof membrane, you're going to have to put an additional air barrier within that roof system. Probably the most popular one is just to put a polyethylene sheet or a self-adhering sheet directly onto the deck, and then you'd run that up your walls and tie it in, or run it under your parapet walls if it's new construction. If you do a few different ways to do it, it's really project specific, obviously. But that's air barriers. So insulation requirements, actually pretty easy to figure out. You get to look at this really pretty colorful map and figure out what, these are all different climate zones. It goes from 1 up to 7. And obviously they kind of, you get into this mountainous region in here, it hits 7. So one thing that's kind of nice in the code, say you have a project around Kansas City, but Well, you're not really sure, are you in 4, are you in 5? Well, that in the code, they list out all the states with different counties. So as long as you know what state and county you're in, you can look up by that, and then it tells you what climate zone you're in. So once you have your climate zone, you take it over to, it's just the next, I think it's chapter 4 in the IECC. And this is a summary of insulation requirements for every code, but say you had climate zone 5 and you're using the 2012 building code, well, you need an R25. And this table references insulation above a structural deck. So it's a steel deck, concrete deck, whatever it might be. This is continuous insulation above that decking. Couple things to note here. You do need to really know what code you're using and if there are any amendments. For example, I'm doing a project right now in Illinois, and I looked up, they used to have their own energy conservation code. They actually just adopted the 2018 IECC, but there are amendments, and the amendments read that if you have flashing height restrictions, or you have you have skylights that you can't raise, or something like that, door thresholds that you can't move, they actually let you reduce your insulation down to a minimum of R20, which is a huge, I mean, it's a savings on insulation costs, but it's also a huge saving on flashing height when you go to detail work. So knowing your code's really important. And another thing to note on here, from 2015 to 2018 was the first time they didn't raise R values since I've been into the industry. They're really starting to focus in on air movement, so I'm hoping those start to stay stagnant for a few more code cycles. Cool roofs, right now they're required. If I go back to this map, climate zones 1 through 3, you're gonna have to use a cool roof, which is, I think a lot of people automatically think single ply, white, TPO, PVC, whatever it might be. There's a lot of different options. You can use a modified bitumen. It's all based on a reflectivity rating. But besides that, California requires it throughout the state. Chicago requires them, and Houston requires them. Those cities are dodging them to try to battle this heat island mitigation or increase the mitigation. They're just trying to block up, it's just all city streets and buildings. So they're trying to throw some white down wherever they can to try to mitigate all that heat being attracted to their cities. Energy savings, a lot of people think, well, if I put a cool roof on, I'm automatically gonna save a bunch of energy because I don't have to cool my building as much. That does make sense. That's kind of why it's required in zones 1 through 3. But as you move north and you start getting into areas, South Dakota, North Dakota, where you're not cooling your building as many days as you're heating it, you start to lose those savings a little bit. So it probably would take a little bit of research on, a project specific basis, whether or not it makes sense to put on your roof. Green roofs are something I thought was gonna maybe take off once I got into the industry and start seeing them more and more, and they really haven't. And the really simple reason is because they're really expensive and they're really difficult to design and install and maintain. There's structural considerations, especially if you're using an existing building, you have to have an engineer to sign off that, these are heavy roofs. Even if you're using a tray system, they still weigh quite a bit. So you need to have sign off and design on that. You're gonna have to hire a landscape professional. You're gonna have to hire or have staff that can take care of these, because once they turn brown and overgrown, they are not as pretty as this one in the picture. And that's what happens to a lot of them, unfortunately. Also leak detection. There are some things out there like electronic leak detection, which works, but you still have to dig up or move a bunch of tray systems out of the way to fix the leak. So those are just additional, expenses. It does kind of sound like I don't like green roofs. I do. They just have their time and place, just like any other roof system. There's just a lot of factors you got to take in if this is the road you want to go down. So talking about existing buildings and kind of some things you need to do to get yourself going. Core samples are wildly important, along with walking the interior of the building. Core samples give you your thickness that lets you figure out how that existing roof is sloped, if it's structural, is it tapered. You get that full thickness of the roof. You need that especially when you go back to start detailing to figure out how much flashing heights you're going to be working with. And then identifying the roof deck type and condition. That's huge to do a deck inspection before you do any sort of roof design on an existing building. If you do find bad deck, it can lead you to finding problem areas on the roof, difficult things to design. It's just it tells you a lot before you get going on the design work. And then you might need to determine any need for asbestos testing. There are still roofs that have asbestos materials on them. You find that in there's corrugated and flat panels that have asbestos containing materials. Then you find them in felts, underlayments, asphalt and coal tar pitch. Some sealants have it, and then some mastics too. So every state does testing different. There's not really a standard for the country. So everything's a little different on how you have to take samples and send those in. So just get with a asbestos professional for that. This is a core sample on a tapered roof. Obviously, as you can see, it shows you how many layers. It shows you the cover board. It gives you an idea of how that existing membrane is still working. Is it working? Is it failing? So core cuts tell you a lot. And then this is just some deck damage on an interior review. This is a gypsum deck that had some failing form board. And this is just a steel deck where you have some corrosions at purlins, which is actually pretty common, especially if you have just a little humidity in that building. And then some additional tests, if you're doing a recover of any sort, or just a straight recover, if you want to put new insulation on your existing roof, you need to do an infrared scan to get any wet materials out of that roof first. A fastener pullout test, those are pretty common on if you have kind of an odd deck, like an aluminum deck, because most fastener pullout that membrane or manufacturers provide usually are on a steel deck, not aluminum. So if you have an aluminum deck, you'll want to do pull tests, along with if you have a lightweight concrete deck or you have a gypsum deck and you want to fasten to it, you'll probably have to do fastener pull tests to figure out what that specific fastener is going to give you. Then a bonded pull test is used if you want to adhere to an existing roof. You'll have to do a bonded pull test or a bubble test. And then this also you can use for a if you have a kind of an irregular surface that you want to put like a self-adhering vapor retarder on, you can do a pull test for that vapor retarder as well.
All right, the next thing we're going to talk about is roof traffic, and we're not talking about driving on your roof. What we're specifically talking about is, do you have other trades that are walking on your roof? Do you have HVAC contractors, plumbers? You see that really quite a lot on heavy industrial sites where you have a lot of equipment up there. Do you have this high-rise building where you have window washers need to access? If you answered yes to either of those, you're going to want to install possibly some additional walkway systems. They have raised platforms, walkway pads. And do you want to install solar? If you're installing solar, there's a lot of things you need to think through in the design process. And the biggest thing is you want to make sure that you design a roof system that has a life expectancy that matches the length of time that you expect those solar panels to be installed. You don't want to have a solar panel that's designed for 30 years and then your roof only lasts 25. Because if you have to uninstall that solar equipment, you're probably going to lose a lot of the financial advantages of having that solar system installed in the first place. You'll want to assess the building structure for that additional dead load, like Andrew talked about. You'll need to have structural engineers involved. If you're having the solar panels themselves rest directly on the roof surface, you'll need to make sure that, yet again, it's designed for that extra traffic. And then before you install it, you want to make sure the roof area is nice and clean. That way you don't accidentally cause punctures underneath where the support stands are. And the last thing we want to talk about today is sustainable roof design. We're seeing this more and more as an important factor for companies. And the first step to having a sustainable roof actually doesn't even begin in the roof design process. It starts in the proactive management of your roof assets, because the longer you can keep your roof in a serviceable condition, means the less debris is going to end up in the landfill. And so that's the easiest way to impact sustainability. There is a lot of things you can do during the roof replacement process. There is a theoretical zero landfill project where you would be able to recycle your membrane, your insulation. You can have your materials delivered without extra packaging. However, you're going to need to do a lot of legwork in the design process, talking to your manufacturers, identifying recyclers to make sure that every step of the way having zero waste is accounted for. So in conclusion, to have a successful roof design, you must first determine the project-specific problems you need to correct, your low flashing heights, your drainage issues, that type of thing. Then compile the list of parameters, including insurance and code requirements. Then compare the different roof systems to identify which roof system will best fit all of your specific requirements. And once you have all that information, you'll be able to identify the best solution for your specific project. And with that, we're going to go ahead and move into the question and answer session. So if you have any questions, feel free to get them submitted. Once again, it should be over on the left side of your screen with a little question mark. Feel free to type those into us, and we have a couple in already. And the first one, Andrew, I'm going to ask you, which membranes are resistant to grease and oil?
It's a good question. Inherently, like right off the top of your head, you think of KEE, like a true KEE sheet that's over 50. That's a blend. So a KEE is a type of a PVC sheet, and they have great chemical resistance. And then this a true PVC. Most of those have better than most, I guess, chemical resistance. Once you get into like asphaltic products, they don't really handle grease that well. Same thing with EPDM. Grease will just kind of eat right through it. So yeah, definitely go with some sort of thermoplastic.
Perfect. Thank you. The next question is getting back into the code conversation, and it's actually interesting. The poll results, we had about 50% that weren't sure which code they follow, and they're asking, how do you know? And the way that I most often go about finding that answer is to call the local city hall, the building department, and that works if you're in a fairly large city. They usually have a building official on staff. You want to be careful of trusting their websites because they can be out of date, and you don't want to design to the wrong set of code. You can also look on iccsafe.org, and they have a listing of all of the codes that are adopted on the state level, so that way you can identify if there's not a local building code. All right, the next question is asking about finding factory mutual assemblies. Andrew, do you want to answer that?
Yeah, so you want to go to roofnav.com, and you'll have to create an account. It's free, but that's how you access their database. Searching their database can be tricky. The more you use it, obviously, the easier it gets. But along with that, RoofNav, if you have an account there, that's also where you're going to find their calculator, and you'll find any sort of references to those data sheets as well. So it's a good site just to go look around at least and make yourself familiar with. There's a lot of good information on it.
All right. If there are any other questions, feel free to get those submitted. Like I mentioned, when we do end the webinar, there will be a survey that will pull up. We really would appreciate your feedback on this session, and if you have any other recommended topics. And looks like we have no other questions, so we will go ahead and wrap this up. Thank you so much for joining us. If you have any questions, feel free to reach out to Andrew or myself, and we'd be glad to help you. Thank you.